Forces, they result from interactions between objects, either pushing or pulling. Once the interaction ceases to exist, the force is no longer exerting on the objects. Newton's first law of motion is often called the law of inertia. If all forces on an object are balanced, the object will be in equilibrium. This ground has no friction, and there are no objects interacting with the cube. Therefore, this cube is in equilibrium. If the net force acting on the object is zero, there will be no acceleration, just like this cube. This will in turn let the cube go at a constant speed and never stop unless an object stops it. Newton's second law of motion is all about net force. It can mainly be summed with this equation. An equation you are more familiar with is. It can also be formally stated as the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. An example of this in action is the varying mass of the same constant force. Sometimes referred to as force diagrams, free body diagrams are used to analyze a situation to see if there is a non-zero net force. Common forces drawn on the free body diagram are normal, gravity, tension, and friction. Going more into the friction force, they are parallel to the surface, independent from the applied force, and are always opposing the direction of motion. There are, however, two types of friction: static friction and kinetic friction. Static friction is the force required to set an object in motion. It will always be less than or equal to the kinetic friction. Kinetic friction is a constant force and is the force that stops the motion of an object. Kinetic friction can be found with this equation. To measure how fast circular motion is affecting an object, this equation can be used to find out the omega, otherwise known as angular velocity. It is measured in radians per second, while tangential velocity is measured in meters per second. When tangential velocity is constant, the radius will change how fast angular velocity is. When angular velocity is constant, the radius will change how fast tangential velocity is. Centripetal acceleration will always be facing the center of the object, while the tangential velocity will be perpendicular to the centripetal acceleration. Because centripetal acceleration is always facing the center of the object, the force will also be facing the same direction. Newton's second law of motion can be written to account for circular motion. Centripetal force equals mass times centripetal acceleration. There are only two changes to the equation: centripetal force and centripetal acceleration. Centripetal acceleration can be found by velocity squared divided by radius, or in a different way, omega times radius. For every action, there is an equal and opposite reaction. This is Newton's famous saying for his third law of motion, where anything you do that consists of force have the same force fighting back in the opposite direction. They are called force pairs. They do not cancel each other out, but rather they work the force on different systems. While Roblox is not a fully accurate representation of this, it shows that the person getting hit with the slingshot is getting pushed back, while the slingshot ball bounces backwards.